Hello people and welcome back to another video. In this session, we'll be taking our discussion from where we left the last time when we were discussing about the critical value in t-test. What are some of the functions that we have in R programming that will help us in calculating the critical value? And I assured you that in our next session, which is this particular session, we'll be discussing in detail one-sided and two-sided t-test. Now, right at the onset, I want to tell you all that the concept is extremely similar to one-sided and two-sided Z-test that we discussed when we were discussing about hypothesis testing. Now, for those of you who are familiar with that concept, you will find this very easy. And for those of you who haven't watched that video or you haven't really familiarized yourself with the concept, I would request all of you all to please watch that video where I have explained that particular concept very in a very detailed manner. But here I will also try and do the same thing, and I'll try to explain it to you in a similar way that we discussed back then. But still, I'll urge all of you all to watch that session as it has more perspectives than just this. So when we talk about one-sided alternate hypotheses in t-test, what we learned was that in case of one-sided alternate hypothesis, there can exist two conditions. Either your alternate hypothesis can be mu is less than mu naught, where mu naught is the null hypothesis or the hypothesis of no change, and your alternate hypothesis can be mu is greater than mu naught. So these are the two one-sided alternate hypothesis one-sided alternative hypothesis conditions that exist. Now, very similar to what we saw in Z-test, in t-test as well, now this is for mu is greater than mu naught. Now for mu greater than mu naught, if this is my critical t value, then we are concerned with this area right here. This is my probability of t greater than or equal to t. Okay, so for alternative hypothesis mu greater than mu naught, we are concerned with calculating this particular area. We are interested in calculating probability of the probability that my point lies somewhere here, somewhere in this area that is beyond my critical value. All right. This is my T critical value. Let me write it as TCL. Okay. Here for mu less than mu naught, I am interested in calculating this area, the area towards the left, exact opposite to mu greater than mu naught. This is mu less than mu naught. Okay. This is P of T less than T. This is the probability that we need to calculate. This is the first condition that we have for alternative hypotheses. For one-sided alternative hypotheses, mu greater than mu naught and mu less than mu naught. Now, when it comes to two-sided alternative hypotheses, then we are interested in calculating both these areas. We're interested in calculating this as well as we're interested in calculating this. So essentially, and because these two areas are equal because of the symmetric property of the t-distributed curve, which is very similar to the symmetric property of standard normal distribution, the area will be twice into P of t greater than or equal to mod of t. Okay. So this is the fundamental idea of one-sided and two-sided alternative hypothesis test for t distribution. Now, if you want a much more nuanced understanding of this, you can watch our previous video when we discuss the same concept for z-test. But to solve problems based on one-sided and two-sided t-test, I think if you understand these three basic fundamental concepts, you are good to go. So we will now dive into two questions, one on one-sided t-test and the other on two-sided t-test. And we will be solving both these questions using the concept of the five-step procedure of hypothesis testing that we discussed in our previous session. So I will request you all to watch that session before you come and watch this session. Alrighty. So before I begin discussing the problem, I want to come come to the five-step procedure in very short brief. So first of all, we decide the null and alternate hypotheses, and we discuss and see what is the alpha value. In step number 2, you need to calculate the test statistic. In step number 3, you need to calculate or basically in step number 3, you need to mention the condition of hypothesis test, or basically your condition of accepting and rejecting the null hypothesis. In step number 4, you can actually go ahead and calculate the critical value and do the comparison. Now, whether to accept or to reject the null hypothesis, there are two routes that you can take. A is the route of the critical value, where you compare the test statistic with the critical value. Or second way is you can actually compare the p-value to the significance level or the alpha value. Now, again, these concepts are discussed in extreme detail when we discuss the five-step hypothesis testing procedure in a little more detail. So you can watch that video in order to understand the concept of the five-step procedure. But broadly, this is what we need to do. So now let us go to the questions so that you guys can have a practical understanding of how it is done. So the question says, question number 1, a scientist wishes to test the claim that the great white sharks average 20 feet in length. To test this, he measured 10 great white sharks. The measurements are given as these are the measurements of the 10 sharks. Are these data good evidence that the great white sharks are longer than 20 feet in length at 0.10 level significance? So in this question, you have been given alpha as 0.10. It means my confidence interval is equal to 0.9 or 90%. Now, with these observations, you have to go ahead and you have to calculate the sample mean. You need to calculate sample standard deviation. You need to calculate the critical t-value at 90% confidence interval or 0.10 significance level. And after calculating all these three, now before calculating all these three, let us go ahead and let us write down what is our null hypothesis and what is our alternate hypothesis. So in this case, my null hypothesis will be that my unknown population parameter mu is equal to 20. Since it is given that as the scientist wishes to test the claim, this is the claim that he wants to test, that the great white sharks average 20 feet in length. This is the claim that he wants to test. So we will take that claim as our null hypothesis. Now, what do we need to find evidence against this? We need to find evidence against this, but in which direction? Both directions or in one specific direction? So the question asks, are these data good evidence that the great white sharks are longer than 20 feet? So when he says longer than 20 feet, the alternative hypothesis will be mu is greater than 20. So this case becomes case for the one-sided alternate hypothesis where mu is greater than mu naught. So now let us go ahead and start our calculation. You don't need to do it manually. You can just do it in R. I will take the measurement and I'll put these values in the vector. So you have 18.1, 23.4, 23.8, 24.1, 22.5, 19, 25.4, 23.1, 16.5, and 26.7. Okay, so this is my measurement vector. I'll calculate the mean. Mean is 22.26. I'll store it in X bar actually. So I'm getting my mean as 22.26 sample standard deviation 3.3083. All right. Now let us calculate the T critical and the T statistic as well. So as I mentioned, when you are doing hypothesis testing, you can, and you need to finalize whether you want to accept or you want to reject the null hypothesis. You can do it in two ways. Either you can do it with the test statistic procedure or you can do it with the p-value procedure. First, we look at the test statistic procedure. So if I'm calculating my test statistic will be x bar minus mu upon s by square root of n. And yeah, before I forget, my n is equal to 10. Also here, my n will be equal to length of my measurement vector is 10. So now T stat this is going to be equal to x bar minus mu. Mu is 20 because that is the initial value at null hypothesis. S divided by square root of n. I'm getting my T stat value as 2.160. Okay. Now what is the critical T value? Now to calculate the critical T value, I know my significance level is 0.1. my confidence level is 0.90, and because this is a one-sided test, it means that I need to find my critical value where the area towards the left is 0.9. Again, a concept discussed very in great detail when we discuss Z test, but let me just briefly explain to you. This is my T curve, and this is one-sided, and I have to calculate it at 90% or zero point 0.9. This is going to be my T critical, and the area towards the left, this is going to be 0.9. So I have been given the area or the probability, and I need to calculate the critical T value. So T critical is going to be T crit is going to be equal to, I'll be using, yep, QT of, I've been given probability as 0.90, and my degree of freedom is going to be n minus 1. I'm getting T critical as 1.383. So my T value is 2.160. My T critical is 1.383. So my calculated T statistic is greater than my critical T value. And when this is the case, we saw in our previous session when we were discussing hypothesis testing that in this situation we can reject the null hypothesis because we have sufficient evidence against the null hypothesis, right? Also, if you want to do it via the p-value, the route of p-value, so 2.160 is the p-value that I have. Now I need to calculate the probability of t is greater than d, since we are concerned about the right hand side. We are concerned about this particular area. My point should lie here somewhere. So this is the case where what we are testing. So we will be using to calculate the probability for this test statistic, we'll be using PT. Now PT gives me the area towards the left hand side, but we want the area towards the right hand side. So if this is my 2.16, I want this area, not this area. So I calculate this area and I subtract that by the from the total area, which is going to be 1 minus PT of, I'll say, T stat and n minus 1. This gives me 0.029. So my p value is 0.029, which is less than 0.1. And therefore, because my p value is less than alpha, we can again surmise that we have sufficient evidence to reject the null hypothesis. Right? So this is a sample question for one-sided t-test. Now let us move on and discuss another sample question on two-sided t-test. I'll keep this and I'll remove these calculations since this is for one-sided. Alrighty. Now, coming to the next question, biologists studying the healing skin wounds measured by the rate at which new cells closed a razor cut made in the skin of a newt. In another experiment, the researchers used the same 18 newts and measured the healing rate after applying a topical therapy that was developed to help speed up healing rates. The difference between the healing rate for each newt with and without the topical treatment were calculated where the positive numbers indicated an increase in the healing rate. The resulting mean of the differences in the sample was 3.2. Mean sample difference was 3.2 and standard deviation of the differences in the sample was 4.5. Let us write these values down. Test whether or not the topical treatment changed the healing rate of the newts at alpha significance level of 0.1. All right. And again, my number of newts is 18. Test whether or not the topical treatment changed the healing rate of the newts at 0.10 significance level. So we need to see whether the difference in the healing rate changed in any way. Okay. So if there was no change in the healing rate, then I could say that the mean of change is 0. So my null hypothesis or H naught was going to be mu is equal to 0. And my alternative hypothesis is, now the question asks test whether or not the topical treatment changed the healing rate of the newts. And when it said the topical treatment changed the healing rate, it did not specify whether it should change positively or it should change negatively. So we have to consider both the scenarios. So my alternative hypothesis is mu is not equal to 0. This is an example of a two-sided t-test. So we need to go ahead and do rest of our calculations. So my confidence level is again 0.9. First, let me calculate my t statistic value and t critical value. So I'll say this is t stat 1. I'll assign this variable that. Similar to my previous problem, the value of test statistic is calculated in the same way, x bar minus mu upon s by root n. So this time it's going to be 3.2 minus 0 divided by, now my sample standard deviation is 4.5 divided by square root of 18, which is coming out to be 3.016. Now I have to compare this t statistic value with my critical t value at 0.9 confidence level. Since this is double-sided, we know that if it's double-sided, then this is going to be my critical value. And this right here, in between, this is going to be, let me draw this a little more carefully so that you guys can understand what I'm doing. Okay, this and this right here. Yeah, this in the middle, this is 0.9. And using the property of symmetry, we can say that these two areas towards the right and towards the left are equal. So if this is 90% and combine these two becomes 10%, so each of them becomes 5%. So if I'm calculating my critical value, Here, this is T critical. So I know that the area towards the left of T critical is 0.9 plus 5% is 0.05, which is nothing but equal to the area towards the left is 0.95. So T crit 1 QT 0.95, comma. How many observations I have? I have 18 observations. So 18 minus 1. So T crit 1 is coming out to be 1.73. Again, you can see in this case, my T value is greater than T critical, and therefore, in this case also, I have sufficient evidence to reject the null hypothesis. Now, I want to end this session by just juxtaposing the idea of confidence interval in this scenario and making you understand how you can use confidence interval also to gather evidence. I know we have discussed this in our module on Z test, but I'll just reiterate that idea also so that we are covering both sides of the spectrum. So for my first scenario, if I have to calculate the confidence interval, and this is for the one-sided part, the one-sided question, but again, I am reiterating confidence interval is always two-sided. So I am going to write down for both of these questions. Now for the first one, my X bar was 22.26. This is my critical T value into what is my standard deviation 3.3083 divided by square root of 10. Okay. Now for the next one, it's going to be 3.2 plus and minus 3 critical into 4.5 divided by square root of 18. Okay. Now let us calculate both of these values. So my lower bound is going to be 26. I will subtract Q norm, sorry, QT in this case. And since I have told you that it's always two-sided, so we will take 0.95 instead. And my degree of freedom is n minus 1 into what is my S value over here? 3.3083, which is S divided by square root of n. Upper bound will be so lower bound is 20.34, upper bound is 24.17. So this comes out to be 20.34 to 24.17. Now for the second part, let me check the confidence interval. Lower bound one is going to be 3.2 minus QT of 0.95, comma, 10 minus 1 is 9 into 4.5 divided by square root of 18. So it starts from 1.25 and it ends at 5.14. It's 1.25 to 5.14. This is the confidence interval for the unknown population parameter for the two-sided t-test. Now, what was my null hypothesis for the first test? My null hypothesis was mu is equal to 20. And for this, my null hypothesis was mu is equal to 0. So as discussed when we were discussing z-test, that when the assumption that we have taken for the population parameter during our null hypothesis, if that does not lie within the confidence interval and it lies outside the confidence interval, then we can say that we have sufficient evidence to conclude that we can reject the null hypothesis because our assumption does not lie within the confidence interval. So because 20 does not lie in this interval and 0 does not lie in this interval, so in both these cases, we have sufficient evidence to reject the null hypothesis, right? So this brings to a closure of this particular session where we discussed two important examples for one-sided and two-sided t-test. And by the end, we juxtapose the concept of confidence interval in hypothesis testing to make sure that we are following what we have learned in our previous sessions and we are keeping both methods sacrosanct when we discuss any concept. This is going to be the same methodology that we'll be discussing when we'll be discussing any new concept going forward. So I would request all of you all to watch this session again if any part does not make sense or you don't have a lucid understanding of any section. And thank you so much for your patience, and I'll see all of you all in the next session. Thank you.